Hello, everyone. So, okay, I will have to speed up a little bit because we are late in the schedule. So, forgive me for maybe being sometimes too fast. So, I will talk about how we can access the data, because we heard about many missions and sensors and new satellites coming in, and it's all the huge amount of data. And if we want to process it, we need to normally now bring the algorithms and our processing chains to the data, or efficiently move the data to supercomputers if we need really high performance. So for me, it's super nice to be here because I attended the first workshop, ESA training course in Lisbon in 2007. So it's a pleasure for me to be here first time as a lecturer. So let's go. So currently, Copernicus data, mostly Sentinel satellite data, you can access in various data hubs. But you can see here there's not only one access point. You had different data hub for Sentinel-1 and 3. Also with some products from Sentinel-3 being at the EUMETSAT dedicated hub. Sentinel-5 was in a different hub, and so on. That's one thing. Second thing is that most of this data was not accessible, the whole archive, without a need for ordering. And as I will show you later on, there are several applications you cannot build on the data if there is a need for ordering. And this is because of this rolling archive policy that only the fresh data was available at these hubs, like 1 year of data or 3 years of data, depending on the data type. And I don't know how many of you already use the Sentinel data on a regular basis, but probably if so, the main point was this Copernicus Open Access Hub, whole Sci-Hub. But the information is that in a month or so, this one will be shut down. So you will have to switch to a new place where the Sentinel data will be made available, which is the Copernicus data space ecosystem. So I advise you to get used to this system because it will be for many years to come the main access point to official ESA products. And not only for getting the data, I mean downloading, but also processing and building some services around it. And my presentation, I mean, it's a lot of information, like specific information, but I guess many of this you will hear this week, but also you can read about it on the website. So I decided to focus on like actually 5 main points, which I think they are revolutionary with this ecosystem, which this ecosystem brings in the sector. So first of all, for the first time, you will have access to all this data, Sentinel data, immediately, so you don't need to order it. So we talk about, at the moment, like almost 40 petabytes of data in immediate access. As already said today, there is around 20 terabytes of daily increase of this repository. And this will be probably much more later on when the ESA Copernicus satellites will come in. For example, like the hyperspectral one will be really huge in terms of volumes. So in a nutshell, this Copernicus data space ecosystem, it's the main point. You will get the official ESA products immediately available. As it was said already today, many times the data is free and open to everyone, but also with some quotas made by European Commission, let's say, with some free services. So some services you can do some processing of the data free of charge. So we started with 35 petabytes, but the estimates are that in 5 years, or even less than 5 years, this will be 85 petabytes of data. And the ecosystem is planned for many years, so that's why I told you that you can get used to it, because at least it's 6 to 10 years of running time. Plus, it's called ecosystem because it should be open. It's not only about the ESA products that you can download or process. There is about services and also gathering community, EO community around it, and I will show you a few aspects of this ecosystem. So in terms of data offer, I mean, I don't have time maybe to go into the details here, but you can basically assume that all the data, Copernicus data, operational ones, will be available there in full temporal and spatial coverage, but Sentinel-1 raw data, like level 0, this is the only product that will be only available in the full archive for Europe, and for the rest of the world will be available only last year. Immediately, if you want to order it, it will be available, of course. So you have all the products from Sentinel-2, level 1, level 2, Sentinel-3. You will have access to many products from Copernicus services, not all of them, for example, not the climate one or not the atmospheric ones, which are not at the image, they are not like image based, but more like a data cube, so they were not fitting here. You have access to contributing missions, like the digital elevation models or very high resolution imagery used for emergency purposes, like with some restrictions to access depending on the user level. There will be also complementary data. So, for example, the Envisat MERIS or SMOS or European coverage of Landsat is already available in the ecosystem. So, saying about Europe and the rest of the world, the idea was that for Europe you will have all these products, the full archive, but basically you can assume that only level 0 for Sentinel-1 is the only one which is not immediately available. But it's also not it's not very often used in the community. I mean, mostly to produce the level 1 product. So the accessibility immediately of the whole archive is one revolution, I would say. The second revolution is in how many ways you can actually access this data. So first of all, you have the Copernicus browser. So it's like a graphical user interface tool where you can search and access and visualize data. If you know the Sentinel Hub viewer, you will see that there are some similarities. It's not an accident. This is exactly this technology made by a company called Synergize. But you have also, if you want to do some bulk processing, and if you you program your algorithms, of course you should use a different strategy through the APIs. And here I say about only the OData and Stack and S3 APIs, where you can search and access the data in the automatic way, and you can query the catalog in various ways with many attributes. I will show you the next slide. But you can have also the APIs from Sentinel Hub and OpenEO. I will give you more details about it in a second. You have a Jupyter lab where you can do some prototyping of data processing directly from the web browser. There are several processors, mostly the official ESA processors. You can actually apply for data like on demand, that we will process them, and you can do it like in an automatic way. And last but not least, you can also, if you want to scale up, there is also infrastructure next to the repository, so you can rent virtual machines or build clusters and do the big processing. So this Copernicus browser, I'll go quickly. So it's a very nice tool where you can query the data, you can look at the certain areas for certain product types. You can have a list of them. You can put some limitation, I don't know, on cloud coverage, of course, of time range, and then you can read all the metadata of these images. You can download single images here. You can also, in this way, you can find a query you can use through the API, so you can use it to build your query to use then in the automatic mode. But there is also many nice features, for example, that you can build in a few clicks. You can build a time lapse of images on a certain area. So for example, here, when we look, you can also do it for various composites or indices. You can use the ones that are predefined. You can build your own. You can also put your own Python script inside, also in the browser, to make it your own demand calculations, the easy ones. So think about time lapse. So if you put the time range and you put the maximum cloud coverage on a certain area, in like a few clicks, you can do this kind of analysis. So I think it's a really nice tool. You can overlay these indices, these images on the 3D also. So it's everything you can do in the browser. But as I said, if you use this data and want to access it from your programming language, you need to use some of the APIs. And I mean, because we have to think about that the repository is so huge that there is no way in accessing the data in traditional way, meaning that you go through the folders and look for certain files. Even I mean, you need to use a query. Of course, if you know the name of the file, like the full name, you can find it. But otherwise, you need to use the query through the list of attributes, through specific collections for the specific area, time, and so on. There is a lot of these attributes, and you can use it also to access, to process, to download, and through, at the moment, these two standards, OData and Spatial Temporal Assets Catalog, which is becoming, I think, a standard in cataloging Earth observation data nowadays. So, and very interesting feature is also OpenEO API, which in my personal understanding, it's kind of response to the ways you can process data in Google Earth Engine, which is super easy. So the idea here is that with various programming languages that you see below in the row below here, you can write in many languages the same scripts. And then you can, through this OpenEO, you can also apply them to many cloud computing infrastructures. So you can really reproduce, you can move your algorithm between them, which was not the case before. And the Copernicus data space ecosystem is additional one that like also this OpenEO will be available. So if you want to do comparisons, even on the performance comparison between the cloud computing platforms, you can do them using this OpenEO API. Instead of learning the new place, the new supercomputing system, and writing your scripts again. Jupyter Lab is just for, probably many of you know that in many places, I mean that you can start coding directly in the web browser, also using the same tools I said with this catalogs of OData and Stack APIs. And as I said, I mean, there is a commercial part of the ecosystem. So for example, I mean, if you want to do big processing, you can rent virtual machines next to the repository. So you can have access to hold the repository from this virtual machine on various clouds. And the first ones were the CreoDias you heard about, but there is also that you can use, for example, the cloud computing infrastructure of T-Mobile. I mean, it's an open ecosystem to various providers of this kind of solutions. Another important aspect is that you should get used to the cloud optimized formats. So in this Copernicus data space ecosystem, we try slowly to transfer many of these products to the cloud optimized format. And the idea here is that for data streaming purposes, so for example, even for this Copernicus browser, where you can really quickly look at the data in like to the images, to make it fast, you need some technology that allows you to download, to gather from the repository only the data you want to show, not without the need to getting the whole image, even if you need only a part of an image, or you downloading the full resolution image if you need a lower resolution because of the zoom factor, for example. So here the idea is that you have in the header, which is in the beginning of the file, you have the information, first of all, about the zoom level. So you have these pyramids, which is nothing new. I mean, this was also already in GeoTIFFs implemented. But you also have information about the position of each tile of the image. So a part of the images. So if you look for the time series for a smaller region, across time through all the images, but it's only a part of the image. You don't need to download all the data because you can get only the parts of these files. And the good information is that the normal GDAL library can read and write this format. But don't be surprised when you will see some products in the ecosystem already in this. And the revolution is in this fact that only because of this technology you can use for example, through the WMS service, you can have the data stream to the browsers where you can visualize the data super fast, although a huge amount of data is actually streamed to make it available. Then another aspect is that I think also first time that the access to public data, but in the commercial tools built around it, are made in a consistent way. And by this I mean that you have this Copernicus data space ecosystem when you have all the official Sentinel data, you can do the self-registration, you can access the data free of charge. But if you want to scale up, if you need more processing power, if you need maybe some commercial data for your analysis to be used together with the Sentinel data, you can do it through commercial services, and Cryodias is one of them, but not only, and there will be more to come. And what is important, you will have the federated identity, so you don't need to register as a different user. You have exactly the same synchronized data offer. You have the same APIs to access the data, so you can switch between both like smoothly without the need. It's the same ecosystem. So that's why this is also a revolution that you can really. Of course, if you go to commercial side, you need to pay, but from the technological point of view, you should stay with your own algorithms and so on, and be sure that you will get the same results and so on. And last, it's one more point about what's going on in the way how data is distributed, EO data is distributed in Europe. I'm writing here that it's not related to ecosystem because I don't want to confuse you, but I put this in the presentation because I think it's also a very huge topic going on at the moment. So the idea not of inputting the data in one central repository, but federating the data from various sources. And this is happening in the Destination Earth program, which was already mentioned here. So the Destination Earth is basically a program of European Commission aiming at building the digital replica of Earth for various reasons. I mean, of course, we want to understand the processes. We want to reconstruct the past. Of course, we do the scenarios, like the climate scenarios. But I think the most important maybe is actually the aim to test the strategies, regulations on the EU level, global level, to test them and do the forecast. I mean, what will happen if we will make certain decisions? And of course, you cannot do this without a huge amount of data. So the Destination Earth, you have these three main components. And one of them is the data lake, which is EUMETSAT is responsible for. And we as a company we implement it. So in this data lake, there is a completely different strategy where the data will be federated with the harmonized data access. So this is a different trend where you want to keep the data in the places where they are. And this is also for Copernicus data space ecosystem, which will be one of these federated data sources with Copernicus data, satellite imagery. But you will have a single catalog, so you can query, you can look for various data from various sources with the harmonized same query. You can also see if the data is in the many locations, so you can choose which one is best for you depending on the performance or, I mean, various reasons. There are some data where they're in more than one place. And so what you will have at the moment in this data lake, it's the ecosystem with the Sentinel data, but also the Landsat imagery of USGS and the Copernicus services, and contributing missions, but also some data from Eurostat, some model data from intercomparison projects, even the aircraft data. Plus, when the program will start producing these digital twins, this will be also accessible through this data access. And the other important aspect in this different way of accessing Earth observation data is that in this way you can federate them through so-called data bridges if you want to process them at the supercomputer. So, for example, the Finnish supercomputing center called Lumi, it's already in this project. So you can use these data bridges and harmonized data access to get the data and process it at the supercomputer and the data from various sources. So I'm telling you this because I think it's also important to understand that there are different ways that we tackle the problem of huge data repositories we have to use in the modeling and various projects. So take-home messages is that in the Copernicus data space ecosystem, you will have the immediate access to all the Sentinel data, full archive with no need for ordering, scalable cloud computing infrastructure for data processing, many interfaces, and the commercial solutions with the really smooth transition between the public and commercial side. And with this, thank you for your attention.
I would like to add something about the data access. So we heard the presentation about the data access for the Copernicus missions, so for all the Sentinels. But what about other data? Because ESA is not only Copernicus, although most people know Sentinel data more than the others. But there are also other missions. So we have plenty of heritage missions. So I will explain you in next slide. We have also the Earth Explorers that you heard before. And we have also third-party missions. So the heritage missions are all the missions that are not operational anymore. So they are Earth observation missions that are not working anymore, not operational one. But ESA is in charge of keeping the archive of the data, so the long-term data preservation program, and to distribute the data to the users. So, for example, if you want to make analysis, historical analysis of some application, maybe for water, for or other applications, and you would like maybe also to access the data from 20 years ago. So this is the point where you would like to use the heritage missions data. Then we have also the Earth Explorers. So you heard already before about the Earth Explorer missions. So the ESA research scientific missions for which ESA is also distributing the data. Just some examples of the missions that are still operating, or maybe those that are already decommissioned, and those that are future missions like Biomass or Flex that you heard also before. So for the heritage missions and Earth Explorers, you can have access. Some of the data are free data sets. So you just go to the website that I will show you later on, and there is a full access, open access to the data. You just need to register. There is a registration to, you need to create an account, and then you have all these data sets for free available. There are also some data sets that are restrained data sets, especially we are talking here about the large volume of data from some of the missions, for which you would need to submit a small proposal, but this is really very, very small proposal. Basically, you have to explain why you want to get the data, and that's it. Data will be still free of charge. Usually it's very, very quick, very short time for the project proposal acceptance. So this is working like that for heritage missions and Earth Explorers. This is the website. where you can find the data. Basically, you can also, if you don't know, for example, what kind of data you want, you don't know name of the mission, you can go there, you can select the thematic area that you are interested in, and you will have all the missions that fit to your requirements, fit to your filters. The other type of data is the third-party mission data, third-party missions in general, third-party mission program. So, we cannot have all the satellites and in all the possible resolutions, frequencies that exist in the world. So there are also some other agencies, there are other owners of satellites that are launching many satellites, and we would like to have the data. So one solution for us, for you scientists, would be to go directly to the agency and request data from there. But what is ESA doing is to facilitate you access to the specific data sets. And sometimes ESA is buying the data set for scientists, European scientists, who can apply through ESA to get the data. Currently we have, as you see here, we have already a history of 45 years of the third-party mission program. But in general, in this moment, we have more than 50 missions available through this program. How you can, still one more slide, the timeline, so you see some examples of the satellites. See that also every year we are adding new satellites from other agencies or other operators. Here is until 2021. I don't know if there is maybe something more in the horizon as well. So you can follow the website to see also the newest opportunities. How we can access the data? So there are a few types of data access ways. One is the immediate access. So you just sign in the same account that I told you before, so you just create your account and you get immediate access to the data. Usually it is for the archive data. And then there are some missions for which you would need the fast approval. So you just, again, request the data access for specific collection, and if approved, usually there is no issue about that. In 2 working days you should get the access to the data. Then there is also another way of accessing data through third-party access. So we provide you a link, and then you go directly to the owner of the data, and you follow the instructions that they give you. Maybe you have to register, maybe you have to also explain why you want this particular data set. And then the last one is the project proposal type of access. So basically, this would apply mostly for some archive data, but also for the new acquisitions. So maybe, I don't know, I want the new SAOCOM data, new acquisitions. So you need to apply with the project proposal, explaining why you need this data, for which area you need it, for which time, and explain exactly what is the data that you need. And then around 2 weeks, more or less, it takes ESA to evaluate your proposal and to give or not to give you a quota for the project. So again, you don't pay for this data, which is nice, because maybe you want to try, you are not sure in your research, maybe you are not sure if you want to use this data, if it is useful for your application or not. This is a very nice way for you to get the data for free. For more information about the third-party mission, you should go to this website. Also from the main ESA website, you can navigate to this website, and you have all the information here about how to complete the project proposal. There are sometimes also announcement of opportunities for some new missions that you can really get new acquisition. You can task the satellite to get acquisition for your specific areas. So this is also very, very nice opportunity. Currently, we have opportunity for SAOCOM data. So if you are interested in SAR data, maybe it could be something for you. This is again the same data portal with all the third-party emission data. You can select, as I showed you before, is similar. Then again, if you are using third-party emission data, ESA would like really to know how you use it, and to promote also, maybe promote your project. You can share with ESA your results, and we have also a lot of success stories on the website, so you can have a look. Maybe there is something that fits your application as well, just to see how you can use other type of data in your research. Then the last two slides, I'm sure most of you, maybe everyone, knows SNAP already. It's the ESA software with which you can process almost all, or maybe now all types of data, of course Sentinels, plus third-party emission data and others. So you will have also exercise today. If you don't know SNAP, you can learn something. We have also other tool, which is called POSAR Pro, and this is used for SAR polarimetric data, a bit more advanced applications, but we also have this software. It always free of charge, of course. If you have any doubts, you can send email to these addresses. So thank you.